in addition to generating text, you've repurposed language models for protein generation, which makes sense to me as, I have a biology background, a neuroscience background. And so, I'm aware, maybe not all of our listeners are aware, that the proteins in your body that do all the functional stuff for you, every imaginable thing that your body can do happens because of, well, except for some relatively small exceptions, but generally speaking, proteins are doing all of the work. And proteins are a sequence, just like they're a one-dimensional sequence, just like a character string, made up of these things called amino acids. And each amino acid has slightly different properties, but you create this chain of amino acids. You could think of them as like letters of the alphabet, and they allow you to create the incredible amount of functional capability that our bodies have. The proteins that allow your eye to see versus your liver to detoxify alcohol, your skin to do all of the things your skin does. I could obviously could go on with examples for hours.
There's a lot of biology out there. Yeah.
There's a lot of things that our body does. And all of it's just encoded by these one-dimensional sequences of a relatively small number of amino acids, 20 something in humans. And it's something that's interesting. So, you have this connection to MoonHub that we talked about earlier, and this is just a stab in the dark. I don't know what your answer is going to be here, but about a year ago, I went to Berlin and I interviewed Ingmar Schuster, who has a startup that does. They're in the business of doing this. They're in the business of creating proteins. Yeah, exactly, exozyme. Mm-hmm. And when I was there with Ingmar, he mentioned your co-founder, Richard Socher, having recently been there at the Merantix AI campus in Berlin. And so I don't know, there just seems like a connection there in some way, which could be spurious.
Yeah, I'll have to meet him one day. My connection to the protein world has evolved primarily through my co-author on the ProGen paper from the Salesforce days. So as you said, we kind of took the control model, trained it for protein generation, called it ProGen. And we were thinking exactly the way you were thinking. There's way more sequences of proteins than secondary and tertiary structures, which are expensive to generate and stuff. So what if we could make a model that just depends on the sequences? That spun out into a startup called Profluent. The CEO there, his name's Ali Madani. Great guy. They've been doing great work because we had shown that you could generate these proteins and you could synthesize them in a wet lab. You could get proteins that did not appear in nature but had better fitness, lower energy, so they were like better overall, better at the tasks that they were designed for, and that became Profluent. So I'm still connected to that world, not through Ingmar directly, but I love to talk to him, and maybe we've met and we could re-meet. But it's, I think to generalize a little bit, continuing to push a lot of these themes of like, okay, deep learning versus machine learning, right? Getting out of the way. And for me, that move is getting out of the way of the algorithms as much as possible. So instead of designing features, don't just make them parameters. And then we kind of got out of the way of transformers. Instead of having this recurrence and our conceptual biases, like let's just have an architecture that more or less just does matrix multiplications and then allows for sharing of information and context. Context, keep adding context, larger context windows, context vectors, whatever it is. Unify as much as possible, because whether it's vision and language or just different parts of language, like code, the fact that code helps with logical tasks in language models, right? Helps you do better on LSAT questions. Like, that's kind of interesting. The fact that literally taking control, which was a model trained on English, and then using that to train on proteins was a much more stable training curve and a faster learning curve than training from scratch. That's odd. What does English have to do with the sequence of amino acids? Well, there's something general enough about learning how to do alignment and do sequence generation or something going on there. Similarity, just at the core of it all. And I think we need to keep pushing all of this into the natural sciences, like more and more. So biology, chemistry, physics. If there was, I don't know if I've said this before, or at least like publicly or in recording, but I think the same way I felt in 2013 about the deep learning transition being good, but our imposition of conceptual tasks and such on how we were doing AI being bad. And so we need to move towards more unified stuff. I feel the same way about like science. Like there's something about the way that we've been doing science that's a little bit constrained by our perceptions and our projections onto the world that perhaps AI, broadly speaking, some sort of computational algorithmic approach could unlock for us. And it might feel very similar, right? It might feel at first that it's less explainable, right? People always go back and forth, well, the move from machine learning to deep learning was less explainable. Mixing all the data, it's less explainable. We can't explain what's really in a word vector anymore. I think there's an opportunity to go after something like really, really fundamental about our understanding of the universe by getting out of the way and just giving as much context to these systems as possible. And I think I keep like a topology book like with me and a couple different branches. I feel like there's something missing that we probably can't figure out, but maybe AI can for us. And we might not explain it in our current terms, but it'll be a much better predictor of how things work. And we'll find use cases for that.
It makes perfect sense to me. I think you're spot on, 100%. I mean, to kind of try to make this maybe a little bit more concrete or explain it in a slightly different way.
Yeah. Please.
When we go to university, you studied philosophy and computer science in separate departments, and those separate departments cover, a kind of a standard curriculum that has kind of evolved over time as like, this is what's important in philosophy. This is what's important in computer science. You're going to learn algorithms and data structures. Everyone's going to do it over here. Mm-hmm. But those constraints of saying this stuff, philosophy stuff belongs over here in this building with these people, and computer science belongs over here. And, some people like you do, study philosophy and computer science. And in some way, your mind might be able to then make connections between them and have interesting ideas about semantic meaning and how natural language models could work or unified models could work. But we can only get exposed to so many different things as humans,
Mm-hmm.
But an AI system can scale way, 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 way more than us. And it can not just be learning philosophy and computer science, but it can be learning every subject and putting all subjects into a high dimensional vector representation.
Or a context window. Yeah.
Right. And somehow, in ways that we might not be able to understand, it'll be able to make predictions or assimilate ideas across all knowledge in a way that a human never could.
Mm-hmm. I think so. And so I'm looking forward to the next few decades of science as we learn how to incorporate these tools more and more, and maybe like our fundamental understanding of the universe will change, and we won't necessarily run into some of the problems we have with it now.